Hi, hello students. Today we're moving on to lesson 20, writing and evaluating expressions with multiplication and division. So today we're going to use multiplication and division to kind of write out different expressions based on information provided to us. So if we look at example 1, so the farmer's market is selling bags of apples. In every bag there are 3 apples. Complete the table. So they give us kind of the first part in one bag. They give us there are 3 apples because it says every bag there's 3 apples. Then it says that there's 2 bags. You want to know how many apples, 3 bags, 4 bags. And then if there's a B number, so just kind of any number of bags, what would I do to that number to create the number of apples? So if we go through and kind of fill this out, well, if there's for every bag, there's 3 apples, so there's 2 bags. That means there would be 6 apples because bag 1 would have 3 and bag 2 would have 3 more. That's 6 altogether. And same thing here. If there's 3 bags, that means there would be 9. So as you can see, the bags of apples should be increasing by 3 each time. If there's 4, well, that means there would be 12. All right, now the last part here says that there's B number of bags. So if I just give you a number of bags, you should be able to determine how many apples are in them. Well, this is when we look at the relationship between bags and how many apples are in it. So what's going on with this number to get the number next to it? Well, if we look at this, 1, how do we get to 3? 2, how do we get to 6? 3, how do we get to 9? And 4, how do we get to 12? Well, based on kind of our information, we're talking about multiplication division. This is a multiplication problem. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9, and 4 times 3 is 12. So we're multiplying the number of bags, which is B, times 3. Remember, we don't write it with an X because we're talking about multiplication with the variable. So there you go. This is our expression. 3 times the number of bags gives us the number of apples. All right, so that's very similar to what we did in lesson 19. We're also doing here, but now we're talking about multiplication. All right, now I have kind of a few additional questions to go along with it. What if the market had 25 bags of apples to sell? How many apples are there in all? Well, based on kind of what we just came up with, the number of bags get multiplied by 3. So if we go ahead and we do that with this problem, oops, I need the arrow. If I had the number of bags, which is 25, I would multiply it by 3. So 25, and then, like I said, multiply it by 3, commuting a property of multiplication, so it doesn't matter in the order in which I multiply. That would give me 75 apples. Let's go ahead and just write out apples because that's what's being represented by the 75. All right, so there you go. So if we're given 25 bags, we multiply the bags by 3, and that gives us the number of apples, which is 75 apples. If we look at the next one, it says if a truck arrived that had this some number, so this is where we get our variable A, more apples to sell. So now they're giving us the number of apples here. How many bags would the clerk use to bag up the apples? Well, now we're going in the opposite way. So now they're telling us if we had apples, what would I have to do to get the number of bags? Well, this is going backwards. So if we have multiplication on this side, the opposite, or the kind of going backwards would be division. So if we're given a number of apples, we divide it by the same number 3 to go back to the number of bags. So on this one, it says the truck arrived with a number of apples. How many bags would the clerk use to bag up the apples? Well, this is now a division problem. So if I'm given a number of apples, I would divide it by 3. So a divided by 3 would give us the number of bags. Now, because this is apples, there's kind of one more little piece that we need here. Because what happens if we have a remainder? What happens if there's leftovers? So what we need to put here is if there are 1 or 2 apples left over, we need 1 extra bag. An extra bag is needed because we can't just have an apple sitting there. We have to put it in a bag. an extra bag will be needed. So let's say that the number was like 22. Well, 22 divided by 3 is 7 with the remainder of 1. We still have to put that apple in a bag. We don't just get rid of it. An extra bag will be needed, so I should actually finish that up. It's just simply not a full bag, and that's okay. So now here's the question. If a truck arrives with 600 apples on it, how many bags would be needed? Well, once again, if we're given apples for A, we divide it, 600 divided by 3, and that would give us the number of bags. So let's go ahead and do that division. So 600 apples divided by the 3 bags. That would equal, hopefully you come up with 6 divided by 3 is 2. And then we have the 2 zeros left over. And this is 200. And of course, what we're talking about here, this is represented by bags. All right. All right. So for part D, for part E here down, this is how are part D, so what we did here, and part B different. So how are these two different? So you're going to write a short little phrase or a couple sentences to talk about how these are different and why they are different. Why did I multiply here and why did we divide here? So you're going to stop the video here and you're going to take a moment, go and write yourself a few phrases here about what we did differently and why we did them differently between E and D. All right, so go ahead and stop the video, finish up E on your own, and then go ahead and move on to the second video. All right, hello students. So let's go over another exercise or another example. So let's go ahead and look at what's going on. It says in New York State, there is a 5-cent deposit on all carbonated beverage cans and bottles. So here you go. Here's kind of the first part of information. 5-cent deposit for every carbonated beverage can and bottles. When you return the empty can or bottle, you get the 5 cents back. So complete the table. So number of containers returned. So if I return 1 container, how much money would I get? Well, for every 1 container, you get 5 cents. So 5 cents would be 0.05. There you go. So if I return 2, well, that means this would go up by 5 cents as well. So that would be 10 cents. Oops, actually, you need to put my dollar sign. Sorry, I forgot. Dollar sign. Dollar sign. Where dollar sign goes in front. If I return 3, that would give me 15 cents. So as you can see, I'm adding kind of 5 cents for every extra one I return. And if I return 4, that would give me 20 cents. So there we go. Well, now it jumps from 4 to 10 and from 10 to 50 and 50 to 100. And then it goes to C. Well, I kind of want to skip these 3 first. First, I want the formula. I want to know what the formula needs to be so that I can understand how I can go from 4 to 10 and 10 to 50 and 50 to 100. It's not just as easy as kind of adding 5 each time like we had here, because we added 1 each time over here. So the question is, if I have C number of containers, how would I figure out the dollar amount? Well, for every container, I receive 5 cents. So if this is $5, this is 5 cents, excuse me. What would I do with 5 cents and containers to come up with the amount of money? I'd multiply it. So just like before, this is 5 cents times C, or 0.05 times C. So to figure out 10, 50, and 100, I just simply do the multiplication. Well, now I go, well, since there's 10 containers here, I'd multiply it by 0.05. So this would be 10 times 0.05. So I'm writing this a little fast, so it might be a little bit not very pretty, but that's okay. And that would give me 50 cents if I do the multiplication. Remember, if I multiply it by 10, the decimal point just goes over 1, and that gives me 50 cents. Well, now 50, well, since we can also look at it this way. Well, since this gets multiplied by 5, remember these are also ratios. This gets multiplied by 5, so does this. So if I just simply multiply this by 5, that would give me $2.50, because 5 times 25 the decimal point kind of stays where it's at. And there you go. So remember, that's also multiplying 50 times 0.05, just like we did with the 10. And that would give me $2.50. And now one more time, I multiply it by 100. Well, this one, if I had 100, well, actually, I'm just kind of doubling 50, right? Because 2 times 50 is 100. If I double that, that would give me $5. And this is kind of the reason why I did my expression first, was to kind of help this situation make it a little bit easier. If I can come up with a 10, well, then I can come up with a 50 and come up with 100 pretty easily based on this ratio relationship. Now, that's from back in chapter 1. Now, but this is the ratio relationship, because every time this goes up 1, this goes up 5 cents. So it's the same relationship all the way through. All right, so that's the table. So now let's go ahead and take a moment. Let's try to answer a few questions. What I'd actually like you to do on this one is I kind of pause the video and kind of try B on your own. I'm going to go over the answer, and then same thing, we're going to do a C, D, and then of course E. All right, so if we look at B, it says, if we let C represent the number of cans, what is the expression amount of money? Well, we kind of already did this one. This is actually the answer right here. If we let C represent the number of cans, how much money? Well, we just multiplied the number of cans by 5 cents. So dollar sign, of course, got to label what this means. So 5 cents times C. Remember, no multiplication, no X here, either a dot or write them next to each other. 5 cents times C. That equals the amount of money that we're going to earn. All right, so if you go ahead, if you tried this one, if you need to, go and pause the video and give this one a try, and then come back and I'll give you the answer. If it says use the expression you found to find out how much money Brett would earn if he returned 222 cans. Well, in this situation, remember, this is the number of cans. C represents the number of cans. So C equals 222. And now I'd go through and I'd just do the multiplication. I would have the 5 cents and we're going to multiply it. Now this time you could use the X if you wanted to, or you can put it in parentheses. This is what you're going to start seeing now too. This is also another way of showing multiplication. When you have two numbers, just putting one in parentheses, this means multiplication. If I went ahead and multiplied this out, we would get $11.10. So there you go. So we have $11.10 if he returned 222 cans. Now that dollar sign line went a little bit long. Let's go ahead and erase that real quick. All right, so if you return 222 cans, he'd multiply it by 0.5, and then or 0.05, excuse me, and he would get $11.10 back. If we kind of keep going here on this one, it says Gavin needed to earn $4.50 returning can. How many cans would he need to earn? Well, now we're kind of given this dollar amount here. We want to know how many cans there need to be. So this is doing the opposite, or going the opposite direction. So since we're going the opposite direction, we do the opposite operation. So if I want to know how much money I need to make this much money, what must I do? Well, I must divide this. Remember, here's fraction bar is a division symbol, by 0.05, and this will give me the number of cans. So if we go ahead and do this division, we go ahead and we kind of do the division, we would get 90 cans. This is the number of cans you would need to come up with the $4.50. There you go. All right, so now we're going to get to the last part, part E. It says how is part D, so what we just did, and part C different? So very similar to what we talked about before. Once again, I want you to write out a short little phrase or a couple sentences talking about how these are different and why they are different. Why did I multiply 5 cents times 222 to get the dollar amount, and why did I divide 4.5 divided by 5 cents to get the number of cans. It's going to take a moment, try to write out a couple phrases about why you think we did that, and then move on to the last video. We're going to go over one more example.